Hey folks, in this video we are going to continue on our good work with using loops. We're going to expand it a bit in understanding how to terminate loops based on their conditions or counters, those types of things. So just a bit of a healthy reminder, a loop is a control statement that repeats code that is within it. Well, I should say indented within it. And the looping structure that we used was the while true statement. And there's another one. We don't have to worry about that at this point. Repeats code that is indented within it. Brilliant. All right, so the very first example I gave you, just to show you what a loop does, was something like this. This is the first line. Cool. I run this, and something crazy like 1 million to 50 million times a second. It is just going this line, this line, this line, this line, this line, this line, just over and over. Okay, it can be pretty boring being a Python program. You know, what kind of life do you live? Just printing 2 lines over and over again. And that's fine. You could use something like this, and we looked at using break and stuff to terminate it if we wanted. But we can also control it using some variables. And why not? Variables are good bits of code. And we're going to make a variable and we're going to call it game state. And we're going to make that true. And we're going to say while game state is true. And I could run this and it will work. And of course it's going to work. This variable is true. This variable, is this variable true? Yeah, it's going to run it. Okay. And I could also be kind of sneaky. I could be a little bit clever. I could also, because I'm working with Boolean variables, I could delete that statement, just put a colon there, and I could stop and rerun, and it will work as well. And that's because we're just shifting this Boolean variable over to here, and it's just going to say while true. And while it's true, it will run. And that's all good. Now, just while we're on to something like game state, why would I call it game state? Well, you don't have to call it game state. First of all, it's a variable. As long as you call it here, the same thing as here. Like we could call it game state if you wanted. As long as they're spelled the same, it will run functional. You could call it skibbity toilet riz, and as long as it's written exactly the same, that makes sense. But we call it game state because it kind of makes a bit of sense. Like, what is the state of the game? Is it on or off? But you could use whatever sort of description that you want. That's the beauty of sort of variables. But again, like while we're on those variables, they have to be spelled the same. If I've got sort of a capital G here, right, which is pretty common, it's going to say like, yo, this is not defined. What are you talking about, man? I don't understand what to do with this code. And we've got some of the similar problems, just a healthy reminder. It's a control statement, you know, put your colon there, right? Put a bit of love. Is your indentation right? Not this one. It'll tell you, hit that tab, make sure it's all nicely indented, and things are working pretty good. Okay? So we can control this with some variables. I could also type false. Nothing's going to run because the statement's false. Cool. All right. Now, if I was to copy and paste some code that I had already written, sometimes it helps to be prepared. Going to hit that Control-C, Control-V, or Command-C, Command-V if you're using a Mac. We could have a bit of code like this. And so now we're asking sort of the user some question, well, a question, and we have a bit of decision logic. And what you'll notice is all of this code is indented within the while statement. That's very important. If it wasn't, it wouldn't be part of the loop. Like if it was something like that, it's not going to run properly. So you've got to make sure whatever you want in the loop is indented within that loop. And we've got our game state, and our game state is true. But we've also become a bit sneaky here. We have said, so you're in a room with a door. How do you escape? And you've got some choices. You could use the door, and by using the door you escape, and then we say game state is false. So therefore it will kill the loop, right? It's going to change this variable to false, and then it'll kill the loop. We could also give up. So you sit down for a while. That's fine. And we've got our else statement to say, you know, we need some commands. It's always good to have that else statement just to tell the user what's going on. So let's run the code. You're in a room with a door, how do you escape? If I was to type something crazy like toilet, the only commands you can give up the door or give up. Okay, that's cool. And, oh, I don't have to stop and rerun. It's a bad habit. I'm still in the loop, so it just repeats. You're in the room with the door, how do you escape? I could type give up. You sit down for a while. I'm still in the room with the door, how do I escape? I could hit door, and then I escape. Okay, so that's very useful to repeat instructions, because what we have had so far is if you had an option, it's a dead end. Like, how do you come back or something? How do you give the option, ask the question again to someone? So that is that's very useful for that. Now, you could 100%, instead of saying game state, you could say break if you wanted. This would still work. We could remove that variable. That, and we would have to remove this. This code is completely legit as well, and there's nothing wrong with doing that. However, sometimes having a variable set as game state can be useful when we have more variables that we want to consider, or the largeness of our game. Okay, and let's have a look at sort of another example, just before I have a look at that, with integers, and where break would not be really useful. So let's say I had sort of a count that was going on. So I had while count is less than 5, we will print count and we will add 1 and print counting is done. And so what this will do is I've made a variable called count. I've set it at 0, and while it's less than 5, we'll print the number, add 1 to it, and repeat. So I could hit run, and it prints all the numbers for us. Brilliant. And just to prove a point as well, I could go, let's print 1,000,000. Boom, 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 boom. Okay, so maybe it's 1,000,000 a second. Maybe 50 million is too much, but you can see how fast that goes. Okay. Now, this is where you couldn't use break to sort of end the program here. It's only going to end when it reaches 1,000,000, or we'll go back to basics and we'll hit 5. If you use break, like, it wouldn't really make sense. You couldn't just put break here. It would just print, it would probably just print 1 or 0. Okay. So it's added 1 and then it just ends the program. So that's not going to do much there. So that's, especially when it comes to integers, that's why we would use our variable. And just to make further explanation, let's use our debug tool. So I'll hit a breakpoint. I'll go over to the debug tool over here, and it'll just be behind me. There we go, console. And I'll show you what I'm doing. Okay, so count is 0. We're in the loop now. Execute that, we print 0, and we add 1. Now the count is 1. Notice how the count's going up, and we're still stuck in that loop because the number is less than 5. But the moment this one here, this line's going to execute, and now it's 5. Well, is count, which is 5, less than 5? No, it's not less than 5. It is 5, so it exits, and so counting is done. So again, that's sort of the debug tool that sort of allows you to unpack that. Now, where we could also do something, bring this back up, open it up. Where we could do something like that is we could combine integers and strings. Okay, we could have a game state and maybe the number of attempts, and this could be sort of a guessing game here. And what we have here is, while the game state is true and the number of attempts is less than 5, we're going to try and guess the secret word, which is carrot. Okay, and all that we've got here is, so we've got the same logic here that we had from last lesson, but incorrect try again, we're also going to increase the number of attempts, right? And then our final bit is if attempts is 5, you have used all attempts, you lose. Let's go through the debugger tool just to unpack these things again. Okay, so I'm going to put a breakpoint. I'm going to go to console and let's run it. Okay, so attempts is 0. Awesome. The game is running. Secret word. Enter your secret word. Skibbity. All right. Game state is still true. The attempts it's 0. But now we go here. Incorrect, try again. Attempts +1. Now we've got attempts 1. Okay. Let's try again. Enter your secret word. I don't know. What do you guys talk about? Ohio? I think that was something back in the day. I don't really understand. Ohio Grimace Shake? Sure, why not? Let's live a little. Alright. So, if secret word is carrot. No. So it's gone to else. Incorrect, try again. We're going to add another attempt. So we're keeping track. This is what it means to keep track of like a condition, which is the game state, or a counter, which you use integers. And we keep going. Okay. And let's go again. Enter your secret word. I could type carrot. Game state is false. You found the secret word. Well done. Game is ending. Now the while loop is done. That's it. Game is ending. Okay. So that is a bit to unpack, but it's worthwhile just having a think about it. Yeah. Peace out.